In this video, we're going to look at simplifying two rational exponent terms. You really need to have your exponential rules memorized, otherwise these problems will be a lot harder. As far as how to use those exponential properties, you want to look for a property that looks similar to the problem that you're given. On the left-hand side, it looks like we have a product raised to a power. There's actually a multiplication in between each of those terms, 8x squared y to the negative 3. So because we have a product to a power, the one rule says we can raise each term of that product to that power. So we'll have 8 to the 4/3 times x squared to the 4/3 times y to the negative 3 to the 4/3. Now the comment I want to make is how you start the problem and the order in which you use the properties may be completely different. However, you should still result in the same answer at the end. We'll take each of these one at a time. 8 raised to the 4/3 is rewritten as the cube root of 8, then raised to the 4th. Remember that the numerator is the exponent and the denominator is the index. The next two for the variables are treated similarly. For instance, x squared then raised to the 4/3. Whenever you have a power to a power, you multiply the powers. So we'll have x raised to the 2 times 4/3 power times, same for the y raised to the negative 3 times 4/3. Now we'll simplify. The cube root of 8 is 2, and then 2 to the 4th is 16. 2 times 4/3, well, that's the same thing as 2 over 1 times 4/3. So we can just multiply across because nothing's going to cancel. That's going to give us x to the 8/3. And then lastly for y, the 3 and the negative 3 cancel out, leaving a negative left over. So we'll have y to the negative 4. We're almost done with this problem. Usually the directions will say write your terms with positive exponents. So because of that, y to the negative 4 will move to the denominator as y to the positive 4. And now that is simplified. Whee! You could have, over here, first brought the y cubed downstairs in the denominator and then gave everything a 4/3 power. That's completely up to you. You should get the same answer. In our right example, notice we're raising it to a negative exponent, but don't worry about that just yet. If you can simplify your fraction first on the inside and then raise to the power, that's a lot better. Smaller numbers equal better. First, let's clean up that fraction. Notice we have a to the 5th in the numerator and a to the 1st in the denominator. So since 5 is bigger, it retains an a to the 4th. Remember, when you have two terms of the same base and you're dividing, you subtract the exponents. Another way to think of that is there's 5 a's up top and 1 a downstairs. So that 1 a cancels off, leaving you with 4 a's up top. With the b's, we'll do it the same way. We have 3 b's up top, 5 b's downstairs. So 3 of the b's go away, leaving you with 2 b's downstairs. Still all raised to the negative 1/4 power. Good. Now our inside fraction is completely simplified. A little trick is when you have a fraction raised to a negative exponent, well, remember, all a negative exponent says to do is take the reciprocal. So we'll just take the reciprocal right now of this entire fraction to get b squared over 16 a to the 4th. but now it's going to be raised to the positive 1/4 power. Positive exponents are better to work with. Now we'll use the product and quotient rule for rational exponents. So basically, since we have one big product and quotient, everything gets the 1/4 power. So we'll have b squared to the 1/4 over 16 to the 1/4, a to the 4th to the 1/4. Just like in our previous example, when you have a power to a power, you multiply the powers. So we'll have b raised to 2 times 1/4, which we'll clean up in the next step. 16 to the 1/4 is the 4th root of 16. And a to the 4th to the 1/4 is a to the 4 times a 4th. Upstairs we have b to the 2 times a 4th. 2 times 1/4 is 1/2, so we'll have b to the 1/2. The 4th root of 16 is 2. And a to the 4 times a 4th, 4 times a 4th is 1, so that's just a. So b to the 1/2 over 2a is your final answer.